All right, so here we go on part 2 of our taking a look at Lab Project 7.2. This microphone's a little on the cheap side. I hope that you can hear me okay. Sounds kind of tinny, but we'll just make the best of it. All right, so what I have highlighted here, the network ID, the host range, the broadcast, which is where we ended at before. All right. So the first thing I want to point out is the term network and subnetwork, or just simply subnet, are used interchangeably. Both of these terms are used pretty common. All right, so you'll hear me go back and forth, but talking about the same thing. And that's the entity that has all zeros in the host field. All right, so we start now by looking at a formula. I've got it labeled Subnet Formula, but it isn't some magical thing that does everything for you. It just reveals the numbers that are going to result from your activity. All right, so the basic formula is 2n minus 2. And that gives you how many subnets are going to be created, or how many hosts are going to be created. You can use it for either one. All right, so without spending a lot of time on discussing the whys, I'm just going to say that in our example, we have to borrow 3 bits in order to create the subnets. So the n is replaced with a 3. So the formula becomes 2 to the 3rd power minus 2, which means 8 minus 2, right? Because 2 to the 3rd power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. A common rookie mistake is to say, oh, 2 times 3, and that's 6. But then minus 2 is 4. It's like, no, not what you want to do. It's 2 to the 3rd power, which means 8, right, equals 8. And take away 2, and that equals 6. All right, now we're working with 3. How do we work with those 3? Well, come on back up here and consider that our Class C address is comprised of 3 network fields and 1 host field. Only the final field is the host field. So we're going to make a change to that host field. What we're going to do is take the boundary that exists right here between the first 3 octets and the last octets. That boundary is where network information ends and host information begins, right at that period. But what we're going to do is push that boundary down 3 positions. So come on back down here and take a look at this now. We've talked about the formula, and now here are 8 bits that are separated into a group of 3 and a group of 5. I'm just going to do the real basic stuff here so you can follow along and hopefully pick up on this. So what I'm trying to illustrate is that we're picking out those 3 bits and just looking at those 3 and what they are worth, right? What they're going to transfer over to, and what can be used there as well. All right, so this column underneath is representing all the available bit combinations that you have when you're just working on 3 bits, right? Do you agree? You can have 3 zeros, and in dotted decimal notation, that's going to equal 0. Or I could have 001, and that's worth 32. Or I can have 010, that's worth 64. But you're going, hey, wait a minute, Poland. What kind of crap are you feeding me here? This looks like 1, and this looks like 2. But it doesn't, because these 3 bits, remember, are the 3 high order bits of a whole octet. So you have to imagine that there's 5 more bits here. But we're only looking at the top 3, and we know the top 3 are worth 128, 64, and 32. So you have to plug those values in here. So hopefully that makes more sense. So this next one where I have 1 plus 1 and 1, right? 0, 1, 1. That means I've got the 64 and the 32 set, and that equals 96. And if we continue down, we can see what each one of the values are. Right? What's this going to be? 128 plus 32. That equals 160. All right? And then this one here, 192, right? 128 and 64. And then the last one with all 3 bits, if you add up 128, 64, and 32, what do you get? Survey says 224. Okay, that was easy enough. What did we just do? What we just did was identify what our subnets are going to be. All right? But wait a minute. The formula says 2n minus 2. What does that mean? It means we got to get rid of 2. Well, how do we do that, Grasshopper? Well, if you look at our column here, we actually have 8 numbers, don't we? Or 8 different lines, right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them there because 2 to the 3rd power is 8. We had 8 different bit combinations. But we have to get rid of 2. And why do we have to get rid of 2? Well, because some places that teach subnetting, many of them, preach that you can't use the all zeros or the all ones subnet. So this is where the 2 comes from, right? The taking away of the 2. And I put a line through them to indicate that they're not going to be used. So what that leaves us with is the first usable subnet is actually the 001, right? And those high order bits, because we're just looking at the We're just looking at the higher end bits, these 3 up here, that are the 3 top ones of an entire byte. Always have to keep that in mind. All right, so what are these things worth now? Here are my 3 high order bits, and we know that's equal to 32 because of that 1 bit. But what do I do when I take my 3 high order bits and I put them back with my original 5 to create my 8 bits again? In order to transfer back into dotted decimal notation, I have to look at all 8 bits here. We know the 001 meant 32 because they occupied the 3 highest positions. But when I add those other 5 back in, now I have to do the full translation. Well, there's all zeros in the host field, so that's still going to be 32. And then this next one, I've incremented. Now what we have to do is we have to look at the 5 bits and ask ourselves, how many different combinations of zeros and ones do we have here? What's that saying a different way is, how much can we increment this bit pattern until we get all the way to the end? Now, all zeros is the very lowest value you can have, and all ones is the highest value you can have with just using those 5 bits. Okay, so the host range is going to be everything in between what is the network number, which the network number has all zeros in the host field. Oh, and by the way, I should point out that we pushed that boundary down, right? There was a dot here, and the boundary used to be there, and we pushed it down 3 bits. Well, that new boundary is here, but we can't put a dot there because then we kind of screw up the dotted decimal notation. So we can't do that. We just have to assume that there's a boundary there. So this 001, this entire 3-bit area, now has become network information to go along with the first 3 octets too. So now we have 27 bits of network information and only 5 bits of host information. Maybe that's filling in some information for you that you were kind of fuzzy on before. All right, so these final 5 bits really are all that there is in the IP address for host information. So we have all zeros. We know that all zeros means network address. What do we know that all ones is representing? We know that it represents the broadcast address. So the broadcast address on the .32 network would be this number, whatever it adds up to completely in a binary number translated to dotted decimal notation. And it equals 62 because we have the 32, the 16, the 8, the 4, the 2, and the 1-bit set. Well, I'm sorry, not 62, 63. Got the final bit set there, so it's going to be an odd number. All right, so there's my network address, or my subnet address. There's my subnet, or my broadcast address at the bottom. Now the host range is everything in between. What's my first host going to be? Well, 32 plus 1, 33. What's the next one going to be? Well, 32 plus, this is in the 2 position, so 34. And I'm just incrementing all the way up. Now I could keep going all the way, but I have a space here to indicate that I'm missing quite a few in between here, because this is going to be my last one that I get to just before my broadcast. That's going to equal 62. All right, so when I transpose that into subnet ID host range broadcast address, very similar to what I did up here with the overall network that originally had 254 hosts on it. Now I have a subnet ID, right, of .32, 192.42.53.32. That's my subnet ID. That's the number that has all zeros in a host range, right, because that's how we get 32. All zeros in the host range. And then my broadcast address over here, .63, broadcasts have all ones in the host field. I come back up here, I verify that yes, my 63 is the number that when I'm looking at just the network portion of the address, it has all ones. And the host range is everything in between, right? Starting from 33 all the way up to 62. So I'm writing it out this way, just like I did for the regular network stuff. All right, let's move on to the next subnet. So after the 001 and the .32 subnet, my next one should be, right, the .64 subnet. So I illustrate that here, but then when I bring my other 5 bits into the equation, right, to do the complete dotted decimal, transpose into dotted decimal, I have to bring in all 8 bits to do that. So here's my original one. That's equal to 64. All right, add one more. The beginning of my host range, 65. The next host, 66. And after that, 67. And that's going to continue all the way up to, if you've sat there and figured it out, added up I just noticed a fundamental error with my stuff here. Let me go fix it. All right, 0, 0, 0, 1, 0. These should all be 0, 1, 0, shouldn't they? Anybody sitting there looking at that going, oh my God, Poland, you got the numbers wrong. You're messing me up here. Sorry about that if I did it. Let me go through and fix them real fast. All right. That represents my subnet over here, right? That's the number I should have had in here the whole time. That's the magic of copying and pasting, huh? Sometimes you get things and they don't quite you don't quite catch the errors that you make. All right. So anyways, back to here. 64, 65, 66, 67. Again, break out the 3 bits. That's our subnet ID information. You got to have all 5 bits to do dotted decimal notation, right? Transposing to it. What's that going to go all the way up to? Any ideas there? If we add those up, the 64, the 16, the 8, the 4, and the 2, that should add up to 94. And then my subnet broadcast would be 95. So there's the second subnet, and I've got it listed here right underneath my first subnet. So you would continue this process through of going to the next subnet ID, which would be 011 or 96, and incrementing your host fields, right, and paying attention to your subnet ID, all zeros in the host field, your broadcast, all ones in the host field, and then everything in between, and you could create the numbers. And in the end, it would look like this, right? Dot 32, 64, 96, 128. And if you notice, these all increment in values of 32, right? And then the broadcast address column over here. And if you notice one thing about the broadcast, right? The broadcast for the first subnet is that number just before the next subnet. And then the broadcast address for the second subnet is the number just before the subnet for the third, and so forth. You'll see a lot of patterns in the addresses there. Now, here's the new subnet mask. I'll put in here the new one. Remember, the default one was 255.255.255.0. It's no longer that. Now it's 255.255.255.224, or in Cedar notation, /27. And that's indicating that we have taken 3 more bits from what used to be the host field, right? The entire octet used to be the host field, but we hijacked 3 bits and used them for subnetting information. All right, now maybe if you go back and you review some pages in the book again and look at the videos from Professor Messer one more time, it may help you to understand more about what is being talked about there. All right, so I hope this helped you to understand Project 7.2 a little bit better and showed you how to do some subnetting.